Hello students, we'll move with the next topic, that is message passing. So operating system provides the mean for cooperating process to communicate with each other. So cooperating processes are those processes which can affect or be affected by other processes. So how this process can communicate with themselves through inter-process communication. So you can see we have a basic structure in which we see we have process P and process Q. They want to communicate, so they must send messages to and receive messages from each other. So to send and receive messages, we need to have a communication link between these two processes. This communication link can be either physical implementation or it can be a logical implementation. So when you say physical implementation, it can be thought of as the hardware bus or a network. Whereas when you say logical link, it can be different methods that we'll see here, that is direct, indirect communication, symmetric, as well as atomic and explicit buffering. So to begin with, so first we'll come to naming. So in the naming, what we are saying here is, so processors wants to communicate, so they must have a way to refer each other. So there must be a way wherein the process have to tell to whom they want to communicate. So this can be either direct communication or it can be indirect communication. So in direct communication, so the process wants to communicate must explicitly name the recipient or the sender of the communication. So say P wants to send some message to Q. So P has to tell that he wants to send a message to Q. Okay, so that is your direct communication. So we have some properties associated with the communication link. So communication link is nothing but the link that is present between the two communicating processes. So the properties associated with the links are, so link is established automatically between every pair of the processes that wants to communicate. So every pair of process that wants to communicate, automatically link can be established. Link is associated with exactly two processes. So between two processes you have a link. Exactly one link exists between each pair of processes. Okay, so these are the properties associated with the link. So then you have two ways of addressing, that is symmetric as well as asymmetry. In symmetry, what you're saying here, we have to give it with the example. So we are using primitives, that is send and receive primitives. So you have to write this example. So send P comma message. So what you're telling, you are telling to which process you have to send the message. That is nothing but what we told in the beginning. You have to explicitly name. So send P comma message is nothing but send a message to process P, whereas receive Q comma message is nothing but receive a message from process Q. So this is your symmetry. Whereas asymmetry, again the first one is same as the symmetry, that is P comma message is nothing but send a message to process P. Whereas in case of receive, you can see instead of the name of the process we have written the ID, whereas this ID is nothing but it is referring the process which wants to communicate. You're not mentioning the name of the process, but you're mentioning the ID of a particular process with whom communication need to be done. So next one you have is indirect communication. So in direct communication, what we said, you have to explicitly name the recipient, whereas in indirect communication the processes are not directly sending the message to each other, they're not directly communicating with each other. Instead they are sending or receiving from what is called as your mailboxes, or it can be ports also. So you can see here again we are giving two primitives, that is send a comma message. So here in direct, when you say send a P comma message, P refers to the process, but whereas indirect communication send a comma message, so A is not the process but A is the mailbox of the corresponding process. So you're sending the message to the mailbox, and whichever receiver is there of this mailbox, he is going to read the data from this mailbox A. Similarly, receive a comma message. So after message there is a closing bracket here. So what is the meaning of this? Receive a message from mailbox A. So in indirect, what you're doing, you're not directly communicating between the processes, but you're sending and receiving the messages to the mailboxes. Again, here you have some properties associated with the communication link. A link is established between a pair of processes only if both the members of the pair have a shared mailbox. So in this case, when can the communication link, or what is the property associated with the link? Both the processors need to have a shared mailbox. Only then communication can happen. Link may be associated with more than two processes. So that is also possible. So more than two processes, link can be there. Okay. A number of different links may exist between each pair of communicating process, with each link corresponding to one mailbox. A number of different links might be present between the pair, okay, with each link corresponding to one mailbox. Next one you have is buffering. The link has some capacity that determines the number of message that can reside in it temporarily. So what do you mean by a link? Between the two processes, you have a communication link. So how much amount of data can be stored in this communication link, or how many number of messages that can reside in this, that is buffering. So this link, or this property, can be viewed as a queue of messages attached to the link. So what you're telling in this buffering is, so we have a link between two processes. How many number of messages can be stored in this link at a time? So it is viewed as a queue. So it is having, it can be either zero capacity, bounded, or unbounded. So when you say zero capacity, what's the meaning of this? It's not possible for us to store any message in the link. So the sender is sending some message and he has to wait. He has to wait until that message is received at the receiver end. So it is not possible for the sender to continuously send the messages, because it can happen that receiver might be at a slower rate compared to the sender. That is zero capacity. Whereas bounded, when you say the queue has finite length L. So suppose you say the queue has a length of 2. Then what is the meaning of that? At a time, at most 2 messages can be stored in your link. Whereas unbounded, so what you can say, we come back to this, length 2 means, so at a time 2 messages can be stored in the link. So the sender can send a message and again he can send another message. So at a time 2 messages can be stored. Whereas in case of unbounded, what happens? It is of infinite length, so it is not required for the sender to wait. So sender can continuously keep on sending the message. That is unbounded capacity. And the last one will go for synchronization. So this passing of messages can be either blocking or non-blocking. Blocking send. So we'll come to blocking. So this blocking and non-blocking can be there at the sender side, also it can be there at the receiver side. So why this blocking and non-blocking is there? That is for synchronization. So A has sent some message, so that should be received at B. So that is synchronization has to be done. So for that we are going for this blocking send, as well as blocking send, non-blocking send, blocking receive, non-blocking receive. So we'll come to blocking send. The sender blocks itself until the message sent by it is received at the receiver. So we'll assume P is the sender. P is sending some message. After it has sent, it will wait until that message is received at the receiver end. Whereas non-blocking send, the sender is not going to wait. He is continuously going to send the message. Similarly, blocking receive. In blocking receive, what does the receiver do? Receiver will block itself until it receives some message. Whereas non-blocking receive, that blocking is not there. Okay, receiver does not block itself. So with this we are done with module 1. So few of the topics we had already seen in our regular classes, so whatever was left out I have done as videos. So I request all of you to kindly refer these videos, since we don't know when the class is going to start, how many days we are going to get. So my request, kindly refer this video and learn with the topics. So you can see here, lot of contents are there. So remember this side headings. So under buffering you have zero capacity, bounded and unbounded. Just understand and you're writing in your own words. Okay, so if you have any queries you can ask me. Thank you.